making a brush monster, and this is adapted from Caroline Alliston's book, Technology for Fun 2. So what you're going to need to make a brush monster, or sometimes it's called a brush bot, is a brush that can stand up on its own without falling over preferably. You're going to need a motor clipped into a holder, a battery holder, an AA battery holder with 2 AA batteries, although scientifically we're going to call these cells, so 2 AA cells. And you're going to need 2 lengths of wire, about this long. You might have a different kind of wire where you're working, so you might have wires with crocodile clips on the end, for example. We'll show you how to use those later on. You're also going to need to make a switch, a small piece of card, a paper clip, and 2 paper fasteners. You're going to need a bottle top, just a milk bottle lid for example would be fine, a biro and some blue tack. So the first thing you're going to need to do is to prepare your wires. I've used some wire strippers to remove about 1 centimetre of the plastic insulation covering the wire from each end of my 2 long wires. Now I said earlier that you might also, or instead, have some wires with crocodile clips on the end. If you've got wires with crocodile clips on the end, you can use those instead of these wires with the wire strips at each end. I've also prepared the 2 wires at the end of my battery holder by cutting one slightly shorter than the other and again removing the outer plastic from about 1 centimetre of each end. The reason I've done that is to make sure that these 2 wires are not going to touch together and cause a short circuit where you're connecting the battery box to itself, which could be dangerous. Now we're going to create the switch for your simple circuit that's going to power your brush monster. So what you need for this is a small piece of card, and you're going to take a paper clip, place it in the middle of the small piece of card and just draw 2 dots at either end inside the paper clip. Put the paper clip to one side, and we're now going to make holes where you've drawn the dots. So we're going to do that for safety. We're going to use a blob of blue tack underneath the card, and we're just going to push through with a biro nice and firmly to make a hole on this end and a hole on that end. So you've then got 2 holes in your piece of card. What you're going to do now is to take one of your paper fasteners and put it through one side, one hole. Don't tighten it too tight at this point because we're going to need to put some wires around it later on. And then on the other end, you're going to take this end of the paper clip and you're going to put that over the hole and press the paper fastener through. So you're securing one end of the paper clip. On the back of your switch, you want to make sure that the 2 ends of the paper fasteners are not touching. So this is your simple switch once it's connected into your circuit. So now what we're going to do is connect together a simple circuit containing the switch and the motor, and of course the battery holder with the cells inside, the 2 AA cells that we're going to be using. So this can be a little bit fiddly, but what you need to do is you need to curve around the metal wire that's sticking out from the end of your wire, put that around your paper fastener, and keep fiddling with it until you're sure it's in place. This end, you're going to connect this end of the wire to the exposed metal wire of your battery holder and twist those 2 metal sections together until they're firmly together and there's a good connection. At the other end of your battery holder, you're going to connect that onto one of the motor connectors. Again, just put it through the hole and twist it until it's made a good connection. This can be a little bit fiddly. There we go, that's a good connection. On the other connection, you're going to add the other piece of wire, and again, just twisting that onto the metal connector until you're sure it's made a good connection. At this point, it's worth mentioning to make sure it is the metal that's connecting to the metal and not the plastic, otherwise you're not going to have a complete circuit. And this part of the circuit here, you're going to, again, just curve the metal end of the exposed wire, and you're going to place that around the paper fastener that has the paper clip attached until it fits firmly. You might need to adjust the back here and just loosen it a little bit to make that a little bit easier. But by the time you've done that, you should have your simple circuit connected together. And what's the next thing to do is to put the cells, the AA cells, into the battery holder so you can test to see if your circuit is working. So just clip those in, making sure that they are the correct way around. And then we should be able to use the switch here, and we can see and hear that the motor is working correctly. You can see that you can open and shut the switch here so that you can check your circuit is working properly. If it isn't working properly, again, go around the circuit and make sure that all of the metal parts are connected to other metal parts, and making sure that you have a complete circuit with no plastic bits in the way. So once you're happy that you've got the simple circuit made and it's working correctly, what you need to do now is to take your brush, and you're going to need to attach the motor and its motor holder to the very front of the brush. So to do that, I'm using a foam pad, a double-sided foam pad that's sticky on both sides. If you don't have something like that, you could use double-sided sticky tape, you could use blue tack, or even something like a cable tie that you could use to secure it on. But the important thing is that the motor hangs over the front of the brush like this. The next thing you're going to need to do is to secure the battery holder onto the back of the brush. So to do that, I'm just going to use some blue tack that I'm going to stick firmly on so that that keeps the battery holder out of the way. Just press that down firmly. Next, what you're going to need to do is to take your bottle top lid, and you're going to make a hole that is off center in the lid. So to do that, we're going to use again our trick with the blue tack and pressing down onto it with a biro pen. So I'm going to make my hole just off center here and just press firmly with the pen through into the blue tack. That's the safest way to do this. Once you've done that, good idea to turn it over and make the hole again, pushing the pen through the other side, so you've just got a really nice, neat hole in the lid there. Something like this. So now we're going to attach the lid with the hole off center onto the spindle of the motor, and we're going to do that just by pushing it on and securing it with some blue tack. Again, you want to make sure that the whole bottle lid is hanging over the front of the brush so that once you operate the circuit, it's not going to hit the brush. If it does, you can make some tweaks later on. So now we're going to test out the brush monster and see if it's working properly. So we're just going to close the switch using the paper clip to complete the circuit and see what happens. So now that you've got a working brush monster, now's the fun part. This is where you get to engineer it yourselves and to figure out how to make it work even better. So remembering, for engineering, we're always looking to test things and see how we can improve them. So you could try things like trying different lids, different types of bottle lids. You could try positioning the hole that you've made to attach the lid onto the motor in different places. You could even try moving the motor and try hanging it over a different side of the brush to see how that affects the movement. So you could also try stabilising your brush. If you find that as your brush moves, it keeps falling over or tilting to one side, I wonder, is there something you could engineer to figure out how to stabilise it? Could you even build a whole extension to the brush that stabilises it as it moves? You could also try making some improvements to your switch. When I was making this switch, one of the wires kept popping out, so maybe you could find a better way to attach the wires to the paper fasteners. And on the back, the paper fasteners sometimes touch together, which means that the circuit completes without using your paperclip as a switch. So I'm wondering if you could come up with any ways to improve your switch and therefore improve the circuit design. Something you could investigate with your learners is what happens if you put the hole in the bottle lid in the centre instead of off-centre. And that's going to help you to find out why the brush monster moves. When the hole's off-centre, quite a lot of vibration is created as the motor spins, and this means that the brush monster can move. Another thing that you could investigate is switching the wires on the back of the motor to investigate the direction that the motor is turning. So now it's over to you to try out some improvements and see how well you can get your brush monster to work. You can use the same circuit and the same idea with the motor and the bottle lid with an off-centre hole to create a vibration on another type of robot. This is called a Scribble bot, and what we've done is to use an old tin can upside down, and we've put the motor on one end, and then we've taped 4 pens onto the side of it, and we've secured all of the wires so that they're out of the way. This one's got a slightly different style of switch that you could try making as well. So for our Scribble bot, when we close the switch and complete the circuit, the vibrations cause it to move and to scribble all over the paper. If you didn't have a tin can, you could use something like a yogurt pot upside down instead, with the same idea. Just make sure you tape all of the wires out of the way before you test it out.